Hello everyone, and welcome to the CSS Beginner course. In this course, we're going to cover everything you need to start working with CSS. You'll learn all the basics step by step, and here are the topics we'll be going through. I'll be doing this on Windows, but the process is the same if you're on a Mac. And by the end of this course, you'll have a solid understanding of CSS and how it works. CSS stands for Cascading Style Sheets. Almost every website you see on the internet uses CSS. It's what makes websites look nice and responsive. HTML builds the structure of a website, but by itself it doesn't look very nice. It's just plain and simple. CSS is the language that controls how HTML looks in the browser. It handles things like colors, font sizes, spacing, layout, animations, basically all the visual stuff. So think of it like this. HTML is the skeleton and CSS is the styling and design. Without CSS, websites would look boring. With CSS, we can create modern, beautiful, and unique designs. Before learning CSS, you should know basic HTML. So learn HTML first, then move on to CSS. If you don't know HTML yet, you can check out my HTML course on this YouTube channel. I'll put the link in the description. It's a good idea to refresh your HTML because we'll use it a lot. HTML and CSS always work together. Now let's talk about what a CSS rule is. A CSS rule has two main parts: the selector, the declaration block. The selector tells the browser which HTML element we want to style. The styles go inside curly braces. Every CSS rule follows the same structure. We'll learn about different types of selectors later. We separate the property and value with a colon, and we end each declaration with a semicolon. Next, let's set up our development environment so we can start writing CSS. First, let's talk about the tools we need for this course. To write CSS, we need something called a code editor. A code editor is where we write our code. I'm going to use Visual Studio Code, but there are many other code editors out there. You can use any one you like as long as you feel comfortable with it. If you want to use Visual Studio Code, you can download it from code.visualstudio.com. After downloading, just follow the installation steps and you'll be ready to start. Next, we also need a web browser. For this course, I'll be using Google Chrome because it has really great developer tools. Now, let's open Visual Studio Code. When you open it for the first time, you'll see a welcome screen. We don't need that, so let's close it. On the left side, open the Extensions panel. Here, we need to install two extensions. The first one is called Prettier. This helps keep our code clean and nicely formatted automatically. The second one is Live Server. This lets us see our web page in the browser right away, without refreshing every time we make a change. Next, open the File Explorer panel and click on Open Folder. Here, create a new folder and name it CSS. You can name it anything you want, it really doesn't matter. Then select that folder to open it inside VS Code. To work with CSS, we need an HTML file first. So create a new file and name it index.html. To quickly create the basic HTML structure, just type an exclamation mark and press Tab. VS Code will automatically generate the basic HTML template for us. In the title, let's change it to CSS Learning. And again, the name doesn't really matter. Use any name you like. For now, I'm also going to delete these meta tags. Now, when it comes to using CSS, there are three ways to implement it. The first way is inline CSS. The second way is internal CSS, and the third way is external CSS. When we build large websites, external CSS is the most commonly used method. But don't worry, we're going to learn all three ways in this course. Now, let's see how to add CSS to our HTML documents. Before that, I want to show you a few changes you can make in VS Code so our workflow becomes better and smoother. So, let's start by creating an H1 element. Now, let's save the file. If you right-click anywhere inside the editor, you'll notice an option that says Open with Live Server. Click that and VS Code will automatically open your web page in your browser so you can see the results instantly. If Live Server opens in a browser you don't want to use, don't worry, you can change it. Here's how. Go to File, Preferences, Settings, then go to the Extensions section and find Live Server Config. Under Custom Browser, you can choose any browser you want Live Server to open with. Now, if you go to the index.html file, you can see that I've been indenting these tags. This is actually a common convention when writing HTML. You don't have to do it, but it makes your code much easier to read and understand. To make formatting our code really simple, we're going to use the Prettier extension. It takes care of all the spacing and styling for us, so our code stays clean and easy to read. At the top, go to File, Preferences, Settings. Then, in the search bar, type Default Formatter. And here you need to select the Prettier. We don't want to format our code manually every time we make a change. So instead, we can tell VS Code to automatically format our code whenever we save. To do that, search for Format on Save in the settings. And then turn it on by ticking the checkbox. So now, whenever we save the file, VS Code will clean up and format our code automatically with Prettier. We already learned that there are three ways to add CSS to a web page. Now let's start with the first one, which is inline CSS. Inline CSS means we apply styles directly to a single HTML element. For example, let's say we want to change this heading color to red. First, here, we need to add the style attribute. Inside the style attribute, we use the color property, then a colon, and then the value we want. This is called a declaration. A declaration has three parts: the property name, a colon, and the value. Now, if we save the file, you'll see the heading turns red. So this is how we add inline CSS. We can also add more than one declaration. It doesn't have to be just one. To do that, we use a semicolon. The semicolon tells the browser that one declaration is finished, and then we can write another one. So let's change the heading's font size. Let's add font size, 20 pixels. If we save again, you'll notice the heading becomes a bit smaller. This is how we add inline CSS. But here's an important thing to remember. This is not a good practice for real projects. In production code, developers usually don't use inline CSS because it makes the code messy and hard to manage. Other developers will definitely complain if you use this everywhere. Still, it's good to know that inline CSS exists and how it works, but it's not something you should rely on for real websites. Now let's see internal CSS. Inside the head section, let's add a style tag. This is where we can write our CSS. When we use internal CSS, we need a way to tell the browser which element we want to style. For that, we use a selector, followed by curly braces. Inside those braces, we can write as many styles as we want. So, for the selector, let's use H1. Now let's copy and paste the same properties and values we used before. If we save the file, you'll see the result looks exactly the same as before. Now let's change the background colour of the whole page. For that, we use the body selector and again add curly braces. Inside, we can write background colour, let's set it to yellow. If we save this, you can see the entire page now has a yellow background. So this is internal CSS. The CSS is still in the same HTML file, but it's kept separate from the actual HTML content, which makes it a bit cleaner than inline CSS. When we use internal CSS, two big issues pop up. First, it doesn't grow well when you have many pages. Imagine you have 5 or 10 pages, and later you decide all your headings should be yellow. With internal CSS, you have to copy the same styles into every single page. And if one day you want to change the colour again, you have to open all those pages and update them one by one. That's a lot of work, so it's not really practical. Second, this method breaks an important rule in computer science called separation of concerns. Basically, it means we should keep different parts of our work in their own place. Styles should stay in one place, content in another. Internal CSS mixes everything together, which is not ideal. And that's why we switched to external style sheets. With external CSS, our styles are written in a separate CSS file. So first, let's create a new file and name it style.css. This is a very common name for the main style sheet. Now I'm going to copy everything inside the style tag. After that, inside the CSS file, I'll paste all the CSS we just copied. Now, if we save this, you'll notice that all the previous styles are gone. This happens because our HTML file and style CSS file are not connected yet. If we want the styles from style.css to show up on our HTML page, we need to link them together. To do that, we connect the CSS file to our index.html file using the link tag. So inside the head section of the HTML file, let's add the link tag. This tells the browser to load our CSS from the external file. As you can see, this tag has two parts. The first one is rel, which tells the browser what kind of file we're linking to. Here, it's a style sheet. The second one is href, and that's just the path to where our CSS file is stored. We can use a relative path or an absolute one, but here I'm using a relative path because both index.html and style.css are in the same folder. So here we can type style.css. And once we save it, you'll see we get the exact same result as before. This is the way we link an external CSS file. The nice thing is, we can use this one style sheet on as many HTML pages as we want. And if we ever need more styles, we can even connect multiple style sheets. That's totally fine. Now, let's take a look at the priority order of these three. So this is the order. This means inline CSS has the highest priority, internal CSS comes next, and external CSS has the lowest priority. Let's see this more clearly with an example. So I'm going to change the heading color using internal CSS. Inside the style tag, I'll set the heading color to blue. If we save the file, you can see the heading turns blue. This happens because the browser says, OK, I found a rule inside the page itself, so I'll use this one instead of the external CSS. So internal CSS overrides external CSS. Next, let's change the heading color using inline CSS. This time, let's set the color to green. Now, if we save again, you'll see the heading turns green. The browser now thinks this style is written directly on the element, so this one is the most important. That's why the text becomes green, no matter what the internal or external CSS says. So when multiple CSS rules conflict, the priority works like this. Inline CSS wins first, then internal CSS, and external CSS comes last. We can change this behavior by using the exclamation mark with the important keyword, or by using different CSS selectors. In the next lesson, we'll look at more CSS selectors. For now, let me show you how important can change the priority. Here, add an exclamation mark followed by the word important to the CSS rule. Now you can see that our heading color changes to blue again. If we want, we can also use important keyword in the external CSS file. So important is a special keyword in CSS that forces a rule to win no matter what. However, using it too much is a bad idea because it makes your CSS hard to manage and debug. I always recommend using it only for testing purposes. CSS is meant to work using order and specificity. Important ignores both of these, which breaks predictability and can cause problems later. I've already explained that out of the three methods, external CSS is the best one to use. But for this course, I'll mostly stick to internal CSS because it's easier for you to see the HTML, the CSS, and the changes all in one place while you're learning. In this lesson, we're going to learn different useful ways to select elements in CSS. One way is to select elements by their type. This is called an element selector. We've already seen how to select elements by their type. In this example, we have two element selectors, H1 and the body. But this method isn't always ideal. For example, imagine we have multiple paragraph elements, but we only want to change the text color of one paragraph. If we use an element selector, it will select all paragraph elements in the document. So the element selector is not always the best choice. That's why we have other types of selectors. So let's talk about class selectors. A class is something we can reuse on many different elements to give them the same style. Here I'm going to add 3 paragraphs. We can use lorem to quickly add some dummy text. Here, let's type lorem, then specify the number of words we want. Let's say 4 words, and then press enter. And then let's copy and paste this paragraph 2 more times. Now let's go to the H1 element and add a class attribute. We'll call the class text. Now inside the style tag, we can target that class by typing dot and then the class name text. Let's say we want a green header. We could say color: green. If we save the file, you can see that our heading is now green. This is how we style HTML elements using the class selector. Now, let's say we want to give the same color to the first paragraph, but not the other two. We only want to change that one paragraph. To do that, we can just add the same class to the first paragraph. When we save the file, you can see that only the header and the first paragraph turns green. Now, let's say we want to underline the text, but only for the heading and the second paragraph. To do that, we need to use another class. Let's call it Special. Next, we add this second class to the H1. We just add a space and then type the class name. Inside the style tag, we write .special and set text decoration to underline. For now, don't worry about these properties and values. We're going to learn them more later in the course. Now, let's save the file. You can see that the heading and the second paragraph are underlined. The third paragraph doesn't have any class or styles, so it stays the same with the browser's default styling. So this is how different elements can share something in common, and we can style them based on that shared thing. An element can have two classes or even more. We just separate the class names using spaces. One important thing to remember is that class names are case sensitive. So these two are not the same. They are two different class names. You can name your classes anything you want, but it's always better to use meaningful names so other developers can easily understand what those classes are for. Okay, next up, let's talk about ID selectors. An ID selector is another way to pick out exactly one specific element on your page and style it. We use it when we want to target something unique, like just one button or one heading. Here we can say ID equals main heading. Now we can style the H1 tag using this ID. So inside the style tag, we start with a £, followed by the ID name. In this case, it's main heading. This is how we write the ID selector. Let's say we want to uppercase heading. Here we can say text transform uppercase. Now, if we save this, you can see H1 is color green and uppercase. One important thing to remember about IDs is that they must be completely unique. An ID should appear only once in an entire HTML document. Because of that, the styles written for an ID apply only to that one specific element, nothing else. Think of it like giving a special name tag to one student in the class. When you call that name, only that one student responds. We can also select elements based on how they relate to other elements. For example, here we have a div with an ID called Intro Section, and inside that div there's a paragraph. If we want to style that paragraph, one option is to give it its own class or ID. But there's another, cleaner way. We can start by selecting the div by its ID, and then select the paragraph inside it. This way, we don't need to add extra classes or IDs, and our HTML stays nice and clean. So if we set the color to green using this selector, the paragraph inside the intro section turns green. This type of selector is called a descendant selector. It affects every paragraph inside the intro section. That means if we add another paragraph inside the same div and save the file, that paragraph will also turn green. As you can see, both paragraphs are now green. Now, let's say we want to apply the green color only to this paragraph. This paragraph is a direct child of the intro section div. The other paragraph is inside another div, so it's not a direct child of intro section. To target only the direct child, we use the greater than symbol between the selectors. Now, when we save the file, you can see that only the first paragraph keeps the green colour, while the other one changes back to the default colour, which is black in this case. This is because the child selector only applies styles to elements that are directly inside the parent element. There's also a selector we can use for sibling elements. To demonstrate this, I'm going to add a paragraph after the intro section. Now, this new paragraph is a sibling of the intro section because they are at the same level in the HTML structure. If we want to apply a green colour to this specific paragraph, we can replace the greater than sign with a plus sign. When we save the file, you'll see that the green colour is applied only to the paragraph that comes immediately after the intro section. If you add yet another paragraph after that one, the new one won't be affected. But what if you want to style all paragraph elements that come after the intro section? So here we can replace the plus sign with a tilde. Now all the general sibling paragraphs that come after the intro section are shown in green. Using relationship selectors keeps your markup tidy because you don't need to add lots of IDs and classes. But there is a downside. These selectors are a bit fragile because they depend on the exact structure of the DOM. If you move elements around, your styles may stop working the way you expect. So only use these selectors if you're sure the positions of those elements won't change later. Now let's talk about group selectors. Group selectors allow us to apply the same style to different elements without repeating the CSS. In this example, we have an H2 heading, a paragraph, and a button. Let's say we want all of them to be blue. We could do this using a class, but instead, let's see how to do it with a grouped selector. We simply list the elements separated by commas. For example, H2, then paragraph, and then button. Then we set the colour to blue. Once we save the file, you can see that all three elements turn blue. So group selectors help us save time and keep our CSS clean and readable. Next, let's talk about selecting nested elements. Nested elements are simply elements that are inside another element. For example, here we have a paragraph inside a div. Inside that paragraph, there's an emphasized word. Outside the paragraph, but still inside the div, there's another emphasized text. Now, let's say we want to underline only the emphasized word inside the paragraph. There are a few ways we could do this. We could add a class or an ID. But using element selectors alone won't work because we have more than one emphasized element. Instead, we can be more specific by selecting the paragraph first and then the EM element inside it. Here, we can simply use the text decoration property and set it to underline. When we do that and save the file, you'll see that only the emphasized text inside the paragraph gets underlined. This kind of selector is called a nested selector. Nested selectors allow us to target elements based on where they are inside the HTML structure, helping us style elements more precisely without adding extra classes or IDs. Now let's talk about attribute selectors in CSS. Sometimes we don't want to use a class or an ID. Instead, we can select elements based on their HTML attributes. In this example, we have 4 links. The first link does not have an href attribute, while the last link has a target_blank attribute. Let's style these links using their attributes. Inside the style tag, we start by typing A followed by square brackets. Inside the brackets, we write href. This selector means select every anchor tag that has an href attribute. Now let's set the text color to green and the font weight to bold. When we save the file, you'll see that only the links with an href attribute turn green and bold. The first link stays unchanged because it doesn't have an href attribute. Next, we can select elements by an exact attribute value. For example, let's write a target equals underscore blank, like this. This selector means select every anchor tag that has a target attribute set to underscore blank. Now, let's change the color to orange. When we save the file, you'll see that only the last link turns orange because it's the only one has this attribute. CSS also gives us a starts with attribute selector. For example, we can write a href and then caret symbol and https. The caret symbol means starts with, so this selector targets all anchor tags whose href value starts with https. Now let's change the font size and set it to 20 pixels. After saving, you'll notice that only the last two links have the larger font size. Next, we have the ends with selector. For example, here we can say a href then $ equals to net. This selects every link whose href ends with net. Let's transform the text to uppercase. You'll see that only the second link changes because it's the only one that ends with net. Finally, we have the contain selector. For this, we use an asterisk. Here, let's say a href, then we need to use the asterisk and then equal, and we can say $O. This selects every link whose href contains $O anywhere in the value. Let's remove the underline by setting text decoration to none. After saving, you'll see that only the third link is affected. And that's how we can style elements using CSS attribute selectors. Attribute selectors are very powerful because they let us style elements based on their attributes without needing extra classes or IDs. We use comments in CSS to explain why we've written certain code. Comments are completely ignored by the browser, so they don't affect how the page looks or works. In CSS, comments start with / and asterisk, and end with asterisk and /. Anything written between these symbols is treated as a comment. In VS Code, there's also a handy shortcut to add comments. On Windows, it's Ctrl+/, and on Mac, it's Command+/. So now the heading goes back to its default color because the color property is commented out and the browser ignores it. If we want to bring the style back, we can simply uncomment it using the same shortcut, Ctrl+/. Once we do that, the heading color becomes red again. You can use comments to describe what your CSS is doing, leave notes for yourself or other developers, or temporarily comment out code while testing. This makes your code easier to understand and much easier to work with later. In CSS, we can define colors in several different ways. Let me show you a few simple examples. Here we have a heading and 2 paragraphs, and each one has a class called Color1, Color2, and Color3. First, we can set colors using color names. These are called named colors. We've already seen this before. For example, let's change the heading color to blue using a named color. Inside the Color1 class, we can simply set the color property to blue. In VS Code, when you start typing a color name, Emmet will automatically suggest available color names for you. Now, if we save the file, you'll see that the heading turns blue. This is the simplest way to set colors in CSS because the browser already understands these color names. CSS actually has 140 predefined color names, and you can find the full list in the MDN documentation. Next, we have hex colors, also known as the hexadecimal color format. Hex colors always start with a hash symbol and use a combination of numbers and letters. The color is made up of 3 parts. The first 2 characters represent red, and the next 2 characters represent green, and the last 2 characters represent blue. Most of the time, a hex color has 6 characters, but sometimes you'll see a 3-character version as well. For example, this value gives us a red color. We can easily recognize the color because VS Code displays a small color preview next to the color value. Now, let's change these 2 letters to zeros. When we do that, this color becomes black because the red, green, and blue values are all set to 0. Now, here's a useful shortcut. If each pair of characters repeats, meaning the last 3 characters match the first 3, we can shorten the 6-character version into a 3-character one. Next, we have RGB colors, which stands for red, green, and blue. With RGB, we mix these 3 values to create colors. Each value can range from 0 to 255. For example, if all 3 values are set to 0, we get black, because there's no red, green, or blue. If we change red to 125, green to 255, and blue to 0, we get a light green color. We also have RGBA, where the A stands for alpha. The alpha value controls transparency and ranges from 0 to 1. 0 means completely transparent, and 1 means fully opaque. So, if we use a value like 0.5, the color becomes semi-transparent. So this is how we can change colors using RGB in CSS. Finally, we have HSL, which stands for hue, saturation, and lightness. HSL is especially useful when you want fine control over how bright or colourful a colour is. But most of the times, we use first 3 different types of colour systems. You don't need to memorise all these colour values. In VS Code, if you click on a colour picker will appear. From there, you can visually choose the colour you want. If you click here, you can also switch between different colour formats and use whichever one you prefer. On top of that, you can always use online colour pickers. They make it easy to find colours you like and simply copy and paste the values into your CSS. So, picking colours doesn't have to be hard. There are plenty of tools to help you. In this lesson, we're going to learn how to change font styles using CSS. First, let's say we want to change the font for the entire web page. To do that, we use the body selector and the font family property. Here, you can see that VS Code suggests a list of fonts you can choose from. These are called web-safe fonts because they are available on most computers. You can use other fonts as well, but for those, you either need to include the font files in your project or link them from an external source. We'll look at that later in this lesson. Now, I'm going to select one from this list. This is called a font stack. A font stack contains multiple fonts. The browser tries them from left to right. For example, the first font here is Arial. When the browser loads the page, it checks whether Arial is installed on the user's computer. If it is available, the browser uses it. If not, it moves on to the next font in the list, which is Helvetica. If that one isn't available either, the browser keeps checking the next fonts in the stack. The last font in the list is a generic font family, like sans serif, serif, or monospace. The exact font used for this will depend on the user's computer. This way, we make sure our text always displays properly, even if a specific font isn't available. Now, if we save this, you can see that the font has changed. Now, let's see how we can add different font families to our website. One great place to find free, open source fonts is fonts.google.com. It's a fantastic resource for adding a wide variety of font styles to your site. For our H2 heading, I'm going to use this font called Gravitas 1. First, let's click the Get Font button. Here we have two options. We can download the font, or we can use the embed code. For this example, I'm going to use the embed code. So I'll copy this link and then paste it inside the head tag of our index.html file. Now that the font is linked, we can apply it to the H2 element using the font family property. Notice that the font name is wrapped in quotation marks. That's because the font name contains a space, and CSS requires quotes in that case. Now, if we look at the web page, you can see that the new font is applied. If the browser doesn't support this font for any reason, we can also add a fallback font, just like we did before. Now, let's look at a few more font-related properties. We can change the font size using the font size property. Let's set it to 30 pixels. We can also change the font style. Let's set it to italic. Next, we can adjust the font weight. Here, I'll set it to lighter. We can also add text decoration. Let's set it to underline. By using these different font properties together, we can fully control how our text looks on the page. So far, we've mostly been using pixels for sizing, but we actually have two other useful units. Let's say I want the word welcome to appear bigger. I can wrap it in a span element. Then I can target that span in CSS and set something like font size 5em. That basically means make this 5 times the size of its parent element. Since the parent here is the H2 and its font size is 20 pixels, the span becomes 5 times that. The nice thing about EM is it's always relative to the containing element, in this case H2. So if we change the font size of the H2, the span will adjust automatically. Next we have rem. Rem is based on the font size of the root element, which is the HTML tag. By default, the root font size is 16 pixels. So if we set a value to 1 rem, it equals 16 pixels by default. If we set it to 5 rem, that means 5 times the root font size, which would be 80 pixels. The important thing to remember is that rem is always calculated from the root font size, no matter where the element is placed in the page. If we change the font size of the parent element, a rem-sized element won't change at all because it only listens to the root. And remember, these different measurement types aren't just for font sizes. You can use them for line height, padding, margins, borders, widths, heights, and many other properties as well. Now, let's look at how to add borders to HTML elements. We'll start by adding a border to this H2 element. If you look at the available border properties, you'll notice there are quite a few. But in practice, we usually work with just three main ones: border width, border style, border color. Let's set the border width to 5 pixels, the border style to solid, and the border color to blue. Instead of using a color name, we can also use any other supported color formats. If we save this, you can see the border applied around the heading. Now, there's a shortcut or shorthand way to write this. Instead of writing each property separately, we can use the border property and provide all three values in one line. For example, we can set the border width to 5 pixels, the border style to dashed, and the border color to red. Here, the order doesn't matter. However, you must include the border style. If you don't, the border won't appear at all. For better readability, it's a good practice to always write it in this order. Once we do that, we can remove the individual border properties. Now, if we save the file, you'll see the new border applied using the shorthand version. Now, there's one more property we're going to look at in this lesson: border radius. With border radius, we can make the corners of an element nice and rounded. A small number gives you slightly rounded corners, while a larger number makes the corners much more curved. Let's set the value to 10 pixels. Now you can see that the border corners are slightly rounded. If we increase this value, let's say to 50 pixels, the corners become much more curved. Now, if we want to round only specific corners, we can do that too. For example, let's say we want to round only the top left corner. We can use the border top left radius property. Here, let's set it to 10 pixels. When we save this, you'll notice that only the top left corner is rounded. If we want to round the entire top edge, we just need to set the border top right radius as well. Now, when we save, you can see that both top corners are rounded. Now, let's look at how to change background colors. By default, our web page's background color is white. So first, I'll select the body element and use the background color property. Here, I'm going to set the background color to green-yellow. Now, if we save the file, you can see the background color has changed. Just like before, here we can use other color formats. Feel free to use whichever color format you're most comfortable with. If you want to use more than one color for the background, you can do that with a linear gradient. We just use the background property and set it to linear gradient. Inside the parentheses, we can add 2 or more colors. Here, I'm going to add these 2 colors. Let's save the changes and see what happens. As you can see, we get a nice color transition. However, there's a small issue. The background repeats once it reaches the last element on the page. To fix this, we can use another property called background repeat and set it to no repeat. Now, if we save again, we run into another issue. There's some white space after the last element. To fix that, we can use the background attachment property and set its value to fixed. Now, when we save, we get a beautiful gradient background that covers the entire web page. By default, the gradient goes from top to bottom, but we can change that direction very easily. At the start of a gradient, we just tell it which way to go. For example, if we write to right as the first value, the gradient will move from left to right. We also have another type of gradient in CSS called a radial gradient. Just like before, we can give it two colours. For example, let's pass white and green. By default, this creates a white ellipse in the centre that gradually transitions to green toward the edges. If we want this ellipse to become a circle, we can do that easily. As the first argument of the function, we simply specify circle. Now you can see a circle in the middle of the page. We can also change the position of the circle. For example, we can say circle at top left. Now, the circle starts in the top left corner and gradually transitions outward. So, this is how we can create gradient backgrounds using radial gradients in CSS. Now let's learn how to add a background image to a web page. First, we need an image. Here, I'm using an image I downloaded from pixabay.com. It's a really good site where you can get free, high-quality images for your projects. Next, inside the body selector, we use the background image property. For the value, we use URL. Inside the URL, we give the path to the image. This can be an online image link or a local image from our project folder. Since this image is in the same folder, we just type the image name. So here it's background.jpg. Now, if we save this file, you'll see that we now have a background image instead of just a background color. But notice something. The image repeats again and again. That's the default behavior. To control this, we use the background repeat property. By default, it repeats both horizontally and vertically. We can also repeat only left to right, or only top to bottom. But in most cases, like this one, we don't want repeating at all. So we simply set it to no repeat. Now, we want this image to sit right in the middle of the viewport. For that, we use the background position property and set it to center. As you can see, the image is now centered horizontally. Now, we need the background attachment. This property controls whether the background image moves when you scroll the page or stays fixed in place. We'll set it to fixed so the image stays put even when we scroll down the page. Now we need this image to fill the whole background area. And to do that, we can use the background size property. We need to set this to cover. Now the image covers the whole background area just the way we want. There's a shorthand way to write all of this. Instead of using separate background properties, we can use just background. We can put everything in one line. The image URL, then no repeat, then the attachment, then the position, and if we want to set the background size, we add a / and write something like cover. The background position and size always go together, and they must be separated by that /. The position comes right before the slash, and the size comes right after it. And as you can see, we end up with the exact same result. And that's basically how you add a background image using CSS. In this lesson, we're going to learn about a special type of selectors called pseudo class selectors. Pseudo classes are not classes that we create ourselves. They are already built into the browser. They help us target elements based on their state or position. For example, we can use them to select elements that don't have a certain class, or to target specific items, like the first child, the last child, or even a specific number using nth child. Let's look at an example. Here we have an unordered list with 10 list items. Now imagine we want to give a yellow background only to the first list item. One way is to add a class or an ID to that item. But instead of doing that, we can use a pseudo class. So we start with the UL element, then add a colon and use first child. After that, we set the background color to yellow. Now, if we save the file, you can see that only the first list item's background color changes. We didn't add any class or ID to that item at all. The browser handled it for us. And this kind of selector is what we call a pseudo-class selector. In the same way, we also have the last child selector. So we can write UL colon last child, and then set something like font weight to bold. Now when we save this, you'll see that only the last list item becomes bold. And one important thing to remember, this is not limited to lists. I'm using list items just as an example, but this can work with divs, paragraphs, or any kind of element. Next, we have the nth child pseudo class. Think of it like a placeholder that lets us target items by their position. So we can select the list items and then write nth-child. Inside the parentheses, we pass a number. For example, if we write 5 and then set text transform to uppercase, when we save the file, you'll see that only the 5th item becomes uppercase. Now, let's say we want to change the text color of every 3rd item. For that, we use nth child and 3, n, and +0. Then we set the text color to green. If we save this, you'll notice that every 3rd list item now has green text. Now, the formula we use inside nth child works like a counter. Here, n is the counter that keeps increasing, and the number after that is the offset. The offset decides where the counting should start. In this example, we're starting from 0. We can also write it this way because the offset is 0, so it doesn't change anything. If we save the file, you'll see we get exactly the same result. Now, let's say we want to change every 3rd item, but we don't want it to start from the beginning. We want it to start after the 5th item. To do that, we change the offset to +5. Now notice what happens. The styling starts from the 5th item, and then it applies to every 3rd item after that. So it starts at the 5th item, and then the next one it affects is the 8th item. We can also style items using even and odd. For example, if we write nth child, and then here we can pass even. This rule will target all the even items in the list. Let's change their background color to light blue. Now you can see that all the even items have a light blue background. We can do the same with odd as well. If we write nth child odd and set the background color to light pink, now all the odd items have their background changed to that color. We also have some pseudo-class selectors just for links. Links are a bit special because they can be in different states. A link can be in its normal state, hover state, active state, or visited state. Using these states, we can style a link differently depending on what the user is doing. Here we have a simple link. By default, links are blue, but we don't have to keep that. For example, we can target all links using the link pseudo class. This one is automatically applied to all normal links. So if we change the color to green and save the file, you'll see the link is now green. Next, let's change the color when the user moves the mouse over the link. For that, we use the hover pseudo class. So we say A, colon, and then hover. And let's change the color to red. And remember, hover is not only for links. You can use it on divs, images, buttons, almost anything. Now if I go and hover over it, it changes red. Next, we have the active state. This happens when you click and hold the mouse button. If we set the active color to yellow, you'll notice the link becomes yellow while you click and hold on it. Finally, we have the visited state. This is for links the user has already clicked before. By default, visited links are purple, but we can change that too. So if we set the visited color to pink and save the file, you'll see the link becomes pink if it was already visited. So these are the main link states, and we can style each one using pseudo classes. Now, let's talk pseudo element selectors. First, we'll look at before and after pseudo element selectors. These let us add extra content before or after an element without changing the HTML. Here we have a paragraph with some text in it. Let's say we want to add something before the paragraph text. We can do that using the before pseudo element selector. So here we can type P and then double colon followed by before. We use double colons because this is a pseudo element. Inside it, we use the content property. For example, let's add an asterisk symbol. When we save this, you'll see an asterisk appear before the paragraph text. If we inspect it in DevTools, you can see the pseudo element. This looks like an element, but it's not a real HTML element. It's something CSS adds for us. That's why it's called a pseudo element. We can also style it like normal text. For example, we can change the asterisk color to red. Now, in the same way, we also have after pseudo element selector. This works exactly the same, but it adds content after the paragraph text. So, double colon before adds content at the start, and double colon after adds content at the end. Now, let's see how we can style only a part of an element, like the first letter or the first line of a paragraph. For this, we use pseudo element selectors again. Here we have a paragraph with some dummy text. Let's say we want to make only the first letter of the paragraph bigger. First, we target the paragraph using P. Then we type double colons, and after that, we write first letter. Now, let's increase the font size to 30 pixels. When we save the file, you can see the very first letter is now larger. Next, we also have another pseudo element called first line. This lets us style only the first line of the paragraph. So again, we write P, double colons, and then first line. Here, let's set the font weight to bold. When we save this, you can see the entire first line is now bold. Now, one more useful thing. When you select text on a page, by default, the background turns blue. We can change that too using a pseudo element. So we write P, double colons, and then selection. Here, let's change the background color to green-yellow. Now, when you select any text inside the paragraph, you'll see the selection color has changed. So, using pseudo elements, we can style small parts of an element without touching the HTML at all. In this lesson, we're going to talk about the box model. In the box model, every HTML element can be thought of as a box. This means that when the browser displays an element, it places that element inside an invisible box. And each of these boxes is made up of 4 main parts. First, we have the content, which is the actual information inside the HTML element. So if you have a paragraph with some text, that text appears in the content area. Next, we have padding, border, and margin, and these are the main properties of the box. The padding is the space between the content and the border of the box. The margin is the space between this box and the other boxes around it. And with CSS, we can customize all these parts to control how each box looks and how much space it takes up. Let's look at an example. Here, I've created 2 div elements, and each one contains some dummy text. Both of them have the same class called box, and each one has its own ID, box 1 and box 2. Now let's start styling them. So first, I'll select the box class, and then I'll add a border. 2 pixels, solid, and the border color, let's say black. Let's also set the width and height properties. We'll set both of them to 200 pixels, so our boxes become perfect squares. Let's also change the font size. We'll set it to 40 pixels. Now I'm going to give each box a different background color. For box 1, I'll select the box 1 ID and set the background color to light blue. For the second box, I'll select the box 2 ID and set the background color to light green. Here we have 2 boxes. Box 1 is light blue and box 2 is light green. But both of them share these basic styles because they both have the box class. Now, let's open the developer tools. Here, I'll select the first div element. In the Styles tab at the bottom, you'll see a visual representation of the box model. The blue area represents the content, and it also shows the size of this area. Next, we have the padding area. Right now, you can see it doesn't have any value. Let's set the padding property to the first box. We can set padding top, padding right, padding bottom, and padding left individually. I'll set all 4 sides to 20 pixels. If we save the file and check in the browser, you'll see that there's now some space between the border of box 1 and its text. Now, if you look at the padding area in our box model, you'll see that there are 20 pixels of padding on all 4 sides. Using the 4 individual properties works, but there's a faster way with the padding shorthand property. Here, we'll simply set padding to 20 pixels. If we save the file, you'll see we get the exact same result. Now, let's try giving only 2 values like this. The first number controls the top and bottom padding. Here it's 20 pixels. The second number controls the left and right padding, in this case 30 pixels. Now if we use 3 values, the first one is for the top padding, the second one is for both left and right padding, and the third one is for the bottom padding. And finally, we can set 4 values like this. The first one is the top padding, the second one is the right padding, the third one is the bottom padding, and the fourth one is the left padding. An easy way to remember which value is which is to think of it like a clock. The values go clockwise: top, right, bottom, left. Next, we had the border property with a value of 2 pixels. Finally, we have the margin property. We could set all 4 sides individually, just like we did with padding. But this time, I'm going to use the shorthand method and set it to 20 pixels. If we save the file, we can see that it adds 20 pixels of space outside the element. Now, I'll set the margin of box 1 to 0 pixels. If we save the file, we notice that even though box 1 has a margin of 0, there's still some space between the viewport and our elements. In the developer tools, if we select the body element, we can see the default styles that the browser automatically applies. On the right-hand side, you'll notice User Agent Style Sheet. This is the browser's built-in style sheet that assigns default styles to HTML elements. For example, it gives the body element a default margin of 8 pixels. That's why we currently see a gap between the viewport and our elements. Now, if we want, we can overwrite these default styles. This is called a CSS reset. There are different ways to do it, but the simplest method is to use an asterisk selector, which selects everything, and then set the properties you want to reset. Here, I'm going to reset the margin to 0. This means we're setting the margin to 0 for all elements on the page. If we save the file, we can see that the gap between the viewport and our 2 elements is now gone. Now for the first box, I'm going to set the margin to 20 pixels and also add 20 pixels of padding on all sides. Now I'm going to add the same properties to my second box as well. Let's save this, and here's what we get. Now I'm going to hover over each of these elements. If you look at the margin area, you might expect that the second box would move down 40 pixels further away from box 1. But it doesn't actually move that far. Instead, the space between the 2 elements is still just 20 pixels, not 40 pixels as we might think. The reason for this is, in the box model, margin actually collapses between 2 elements that are next to each other. Here, the top margin of the second element is collapsed into the bottom margin of the first element. This is called margin collapsing. For example, if we change box 2's margin to 30 pixels, the space between the boxes becomes 30 pixels. Even if we reduce box 1's margin to 0, the space between the boxes still remains 30 pixels. This happens because when 2 elements are next to each other, and one or both of them have a margin, the browser only applies the bigger margin instead of adding them together. In the box model, there's one more thing I want to explain. If we hover over box 1, you'll notice that in the bottom left corner, it shows the size as 244 by 244, even though we set the height and width to 200 by 200. This happens because, by default, the box model adds the padding and border to the height and width of an element. So for the height, we set the height to 200 pixels, and then we added 20 pixels of padding on the top and 20 pixels on the bottom, and that adds 40 pixels. We also added a 2 pixels border on the top and 2 pixels on the bottom. That adds 4 pixels. So when you add those together, we get 244 pixels. That's why the height shows as 244 pixels. And the same calculation applies to the width as well. Also, keep in mind, margin is not included in the element size. The browser doesn't count margin when calculating the height or width of an element. It will just move this box away from other boxes. Now let's look at how we make the element's real size match the height and width we set. For example, 200 by 200. Because calculating the actual size of an element can get a bit tricky, we don't want to deal with that every time. That's where the box sizing property comes in. By default, it's set to content box. But if we change it to border box, the size we set will include the padding and border too. Let's add this property to our first div and see how it works. What border box does is it makes the height and width include the padding and the border. That means the size we define becomes the final size of the element, instead of growing bigger because of padding and border. Now, if we save this and select box 1, you'll see that the content area is 156 by 156 pixels. But if we look at the second box, the one without the border box sizing, you can see that its height and width still show as 200 by 200 pixels. But when we used border box, the browser subtracted the padding and border from the content area, so the content became smaller to keep the overall size at 200 by 200. Now let's talk about outline. An outline is like a border, but it goes outside everything. You can think of it as a border around a border. Outlines are very important for accessibility. For example, when you hover over a button or press the Tab key on your keyboard, you might see a yellow or red line around the element. That line is not a border, it's an outline. It helps keyboard users and visually impaired users understand which element is selected. Here, we already have a box with a blue border. Now, let's add an outline to it. Here, we can write outline 10 pixels, solid, red. When we save this, you'll see the red outline appears outside the border. Now, if we open the developer tools and look at the box model, notice something interesting. You'll see content, padding, border, and margin, but you won't see the outline there. That's because outlines are not part of the box model. They do not take up space and they do not affect the layout. Borders affect size, outlines don't. We can also control how far the outline sits from the element. For that, we use outline offset. If we set outline offset 20 pixels, the outline moves further away from the box. So outline is very similar to border, but the big difference is that outline sits outside the element and does not take up any space. We often use outlines to show focus, like when you click on an input box or a button. So remember, outline is mostly used for highlighting elements, not for layout. In this lesson, we're going to talk about the display property. The display property tells the browser how an element should behave on the page. It controls things like where the element sits, how much space it takes, and whether it starts on a new line or not. With the display property, we mainly use 4 values: block, inline, inline block, and none. In HTML, elements are generally grouped into block-level elements and inline elements. Let's first look at block level elements. So, these are examples of some block level elements. These elements always start on a new line. They also take up the full width available by default. Because of that, we can easily apply width, height, margin, and padding to them. Here, we have two div elements. As you can see, even though the content inside them is small, each div still takes the full width of the screen. Also notice that each box starts on a new line. This is because div is a block level element, and block elements always take full width and stack one below the other. Next, let's talk about inline elements. These are examples of some inline elements. Inline elements stay on the same line and don't start a new line. They only take up as much space as their content needs. Here we have two span elements. As you can see, they appear side by side on the same line, and their width is only as much as they need. Now I'm going to apply width and height to all four elements. First, for the div elements inside the box class, I'll set the width to 100 pixels and the height to 100 pixels. Then, for the span elements inside the text class, I'll also set the same width and height values. Now if we save the file, notice this. Only the div elements are affected. Their size changes, but the span elements don't change at all. They stay the same size. That's because inline elements don't respect width and height. So right now, nothing is happening to the span elements. To fix this, we can change how these elements behave using the display property. By default, div has display block, so there's no change there. But if we set the span elements to display block, now the width and height work. You can see that the span elements now behave like block elements. So using the display property, we changed the default behavior of spans, and now all four elements are displayed as blocks. Now let's change the display property to inline for both classes. Now all four of these elements are inline. We can't apply width or height properties to these elements. Inline elements only take up as much space as they need, nothing more. Next, we have inline block. This works like a mix of inline elements and block elements. Like block elements, we can set their width and height. But like inline elements, they don't jump to a new line. They stay on the same line. So we'll end up with four boxes sitting next to each other, but each box will still have its own size. So if you want an inline element to have a set width and height, you need to change it to inline block. Now, the last main display type you should know is display none. Display none makes the element behave like it's not even in the HTML, almost like it was completely removed. So the display property controls how an element appears and behaves on the page. Some elements act like big boxes and start on a new line, while others stay in line like normal text. The display property also decides whether we can set width and height or align items easily. By changing the display value, we control the entire layout of our web page. In this lesson, let's talk about how to hide elements. Earlier, we saw that we can hide elements using the display property, but there's another way to do this, and that's using the visibility property. Here we have two boxes. First, If I set Display None on the first box, you can see it completely disappears. It's like the box was never there, so the second box moves up and takes its place. Now, instead of display, let's use visibility. By default, visibility is set to visible. If I change it to hidden, the first box is no longer visible. But notice something important here. The space for that box is still there. That's why the second box doesn't move up. It stays in the same position. So the difference is simple. Display None removes the element completely from the page layout. Visibility Hidden hides the element but keeps its space. That's how these two properties work differently. In this lesson, let's learn how float works in CSS. The float property pushes an element to the left or right side of its container. In the past, people used floats a lot to create layouts. Here, we have an image and two paragraphs. Let's say we want the first paragraph to sit next to the image. To do that, we use the float property. So let's apply float left to the image. This moves the image to the left side. When we save, notice something important. Not just the first paragraph, but the second paragraph also moves around the image. This happens because when an element is floated, all the elements that come after it will flow around it. That's how float works. But we don't want the second paragraph to wrap around the image. So to fix this, we use the clear property. I'll create a class called clear and set clear left because the image is floated to the left. Then I'll apply this class to the second paragraph. Now when we save, the second paragraph moves below the image. We can also float elements to the right. If I change the image to float:right, it moves to the right side. But again, the second paragraph wraps around it. Why? Because our clear value is still set to left. Since the image is now floated to the right, we need to change clear to right. After saving, the layout looks correct again. This shows an important problem with floats. If you change float direction, you also need to remember to update the clear value. To make this easier, we can use clear both. This clears both left and right floated elements. So no matter how the element is floated, it will work correctly. Now, if we switch the image back to float left, everything still works fine. So here's the key thing to remember. Floated elements affect everything that comes after them. You almost always need to clear floats. Floats can cause weird layout issues if you forget this. Because of all these problems, floats are not good for building layouts anymore. In the past, we used floats because we didn't have better tools. Today, we use Flexbox and Grid, which are much easier and safer. So use floats only when you really need them, and use Flexbox or Grid for layouts in modern CSS. In this lesson, let's talk about text alignment and also auto margin. First, we'll look at text alignment. Using the text align property, we can move text to the left, center, or right. By default, text is aligned to the left. If we want the text in the middle, we set the text align property to center. When we save, you can see the text moves to the center. If we change it to text align right, then the text moves to the right side. So basically, with text align, we control where the text sits. Most of the time, we only use left, center, or right. Now let's see how to center a box on the page. Here we have a box that's 200 pixels wide and 200 pixels tall. To center it horizontally, we can use Margin Auto. This makes the browser add equal margin on the left and right, which pushes the box into the center. So let's add this property to the box class. Now you can see the box is perfectly in the middle. If we inspect it, it's clear that the margins are equal on both sides. And if we resize the browser window, the box stays centered in the viewport. In this lesson, let's talk about overflow. Overflow controls what happens when the content inside a box is too big to fit inside that box. Every element has a width and a height. If the content inside needs more space than that, it starts to spill outside, and that's called overflow. The overflow property tells the browser what to do with that extra content. Let's look at an example. Here we have a div with a class called box, and it has some text inside. In this case, there's no problem because the box is big enough to hold the text. Now, let's make the text much longer. Now, when we save, you can see the text goes outside the box. That's overflow. So now we can use the overflow property to control how the extra content behaves when it goes outside the box. By default, overflow is set to visible, which is why we can see the extra text. If we change overflow to hidden, the extra text gets cut off and hidden. Another option is scroll. When we use this, the browser adds scroll bars, both horizontal and vertical, even if we don't really need both. Finally, we have auto. With auto, scroll bars appear only when the content actually overflows. Now, when we change the paragraph back, you can see the scroll bars are gone. They only show up when the content overflows. If there's no overflow, the scroll bars stay hidden. So, overflow lets us control whether extra content is shown, hidden, or scrollable. In this lesson, we're going to learn about shadows in CSS. There are two types of shadows: text shadows and box shadows. First, let's talk about box shadows. Here we have a box with a green background color. To add a shadow to this box, we use the box shadow property. Here we need to provide a few values. The first value is for the x-axis, which controls the horizontal distance of the shadow from the element. The second value is for the y-axis, which controls the vertical position of the shadow. For now, I'm going to set the y-axis value to 0 pixels. To make the shadow appear, we must define at least these two values. If we don't set them, the shadow will not be visible. Here, we use a positive value for the horizontal distance, so the shadow moves to the right. And a negative value moves it to the left. The second value controls the vertical position of the shadow. A positive value moves the shadow down, and a negative value moves it up. If we use negative values for both, the shadow appears on the top left side. If we want the shadow at the bottom right, we use positive values for both. So the larger these values are, the farther the shadow moves from the element. Now, if you want to change the shadow color, we can do that as well. By default, the shadow color is black. Let's say we want to change it to a grey shadow. So if we save this, you can see that the shadow colour changes to grey. Now let's say we want a blurred shadow. If we want the blur to be 5 pixels, we just add that as the third value. This value comes after the y-axis offset and before the colour value. Now you can see the shadow looks much softer. And if we increase the blur value even more, the shadow becomes even softer. At this point, the shadow is very light and we can barely see it. Now let's say we want the shadow to appear on all 4 sides of the box. To do that, we set the x and y values to 0. That places the shadow directly under the box, all around it. You can also apply multiple shadows. Just separate each one with a comma. So that's basically how you add shadows to elements. Now, let's see how to add shadows to the text. To add a shadow to text, we use the text shadow property. It works the same way as box shadow. We give it 3 values and a colour. The first value is the horizontal offset. The second value is the vertical offset. The third value is the blur amount. And then we set the colour. If we save this, here's what we get. The text now has a red shadow, slightly down and to the right. We can also add more than one shadow by separating them with commas. And that's how we add shadows to our HTML elements. In this lesson, we're going to look at different ways to position elements. In CSS, we use the position property to control how an element is placed on the page. It has 5 main values: static, relative, absolute, fixed, and sticky. Static is the default one, and it doesn't really change anything. When an element is static, properties like top, bottom, left, right, and z-index won't work on it. Once you change the position to any of the other values, then you can start using those properties. Here we have 2 boxes with different background colours. So if we set the position property to static for the second box, you can see that nothing changes. The element stays exactly where it was before. Now let's look at relative positioning. With this, the element moves from where it normally sits on the page. So we're shifting it from its original starting point. In this example, the box starts from the top left corner, and that's the point we're moving it from. Once we set position relative, we can use top, bottom, left, right, and z-index. For example, let's move this box 50 pixels from the top and 50 pixels from the left. Here, let's set top to 50 pixels and left to 50 pixels. And when we save this, you'll see the second box has moved 50 pixels down and 50 pixels to the right. So it's been pushed toward the bottom and the right side. We can also use negative values here. When we do that, you can see the box gets pushed off the screen. Notice something important. The first box stays exactly where it should be. Moving the second box doesn't affect the first one at all. You can also see that the boxes are overlapping now, and the second box is on top of the first one. That happens because the second box comes later in the DOM. But we can control this using the z-index property. So here we can set the z-index. By default, every element has a z-index of 0. We can use positive or negative numbers to move elements forward or backward. Let's set this value to -1. Now when we save this, you can see the second box goes behind the first one. If we give an element a positive z-index, it will sit on top of other elements. The exact number isn't that important. It can be 1, 10, or even 1000. What really matters is this. The bigger the number, the higher that element appears compared to the others. So with relative positioning, we can move an element relative to where it normally is. And doing this doesn't affect any of the other elements on the page. Next, let's talk about absolute positioning. With absolute positioning, an element is placed relative to its closest parent that has a position other than static. If there's no such parent, it will be positioned relative to the viewport. First, I'm going to add a paragraph with some dummy text below these boxes. Now let's set the second box position value to absolute. Now when we save this, you'll see the paragraph has moved up as well. It's now sitting underneath the second box. The reason for this is that when we set an element to absolute, it's taken out of the normal flow of the page. That means, from the parent's perspective, the element isn't there anymore. You can think of it as being on a separate layer. So on this page, the browser only sees the first box and the paragraph normally. The second box sits on a different layer. In short, when you absolutely position an element, it's removed from the normal layout, and all the other elements behave as if it doesn't exist. If I set top to 100 pixels and left to 100 pixels, the box moves down 100 pixels and to the right 100 pixels. It's positioned relative to the viewport because the viewport acts as the parent for this box. Now I'm going to position the second box relative to the first box. To do that, we need to put the second div inside the first div. Now the first box becomes the parent of the second box. Next, we need to set the first box's position to relative, because right now it's using the default static position. Now, if I move the first box, the second box will move with it and stay in the same relative spot. To test this, let's move the first box 200 pixels down and 200 pixels to the right. You can see the second box moves along with it because it's positioned relative to the first box. So with absolute positioning, the element looks for the nearest parent that has a position other than static, like relative. If it can't find one, then it uses the viewport as its parent. Next, let's see fixed position. An element with position fixed is locked to the viewport. That means it's always placed relative to the screen, not the page content. So even when you scroll, it stays exactly where you put it. That's why fixed positioning is often used for nav bars that stay at the top. Right now, we don't have enough content to scroll. Now, inside the body selector, if we give the height a large value, we'll get a scroll bar. Let's set it to 5000 pixels. And as you can see, the scroll bar shows up. Now let's set the second box to position fixed. When I scroll, you can see the second box doesn't move at all. Now when we set top to 0, it places the element right at the top of the viewport. So it always stays at the top, even when you scroll, because the second box is now positioned relative to the viewport. Next, we have sticky positioning. It's kind of like fixed, but it only sticks after you scroll to a certain point. So the element scrolls normally at first, and once it hits that spot, it sticks to the edge you set. To show this, I've added a few paragraphs with a lot of text so we can scroll the page. We often use sticky positioning for menus because many times we want the navigation to stay visible while we move around the site. If I set top to 0, the second box will stick to the top once we scroll past it. And if we want, we can also make it stick to the bottom by setting bottom to 0. Now, when we scroll up past the second box, it sticks to the bottom. We can even use both together. So when we scroll down past it, it sticks to the top, and when we scroll up past it, it sticks to the bottom. In this lesson, let's talk about transformations. A transformation lets us rotate, scale, skew, or move an element from its initial position. Here we have a div with the text hover me and a class called box. First, let's style it so it actually looks like a box. We'll set the width and height to 200 pixels. For the background color, I'll set it to light coral. If we save this, here's what we get. Here you can see the font size is small, so let's increase it to 40 pixels. And let's also change the text color to white. We'll center the text using the Text Align property. We'll also set the line height to 200 pixels, so the text sits perfectly in the middle of the box. Finally, let's center the box on the screen by setting the margin to 100 pixels and auto. Now, let's apply some transformations to this box. To apply a transform to this box, we use the transform property. I'm going to apply the transformation on hover. So here, let's say box, hover. Then we can set the transform property. There are different functions we can use here. First, let's try rotate. Inside the parentheses, we pass the number of degrees we want to rotate. Let's rotate it by 45 degrees. Now, when we hover over the box, you can see it rotates 45 degrees clockwise. If we use a negative value, it rotates counterclockwise. Next, let's try the skew function. This tilts the element left or right. Let's pass 20 degrees. Now, when we hover over it, the box tilts to the left. If we use a negative value, it tilts to the right. We also have scale function. Using this, we can make an element bigger or smaller. Let's set it to 2. Now, when we hover over the box, you can see it becomes twice its original size. If we use a smaller value, like 0.5, it becomes half of its original size. We can also move elements around the page without using the position property. We do this with the translate function. These are the different translate functions we can use. If I set translate x to 50 pixels, the element moves 50 pixels to the right when I hover. If I use a negative value, it moves to the left. If I use translate y 50 pixels, it moves 50 pixels down. A negative value moves it up. We can also combine both using the translate function. Here, let's say 50 pixels on the x-axis and 50 pixels on the y-axis. Now when I hover over it, it moves the element 50 pixels right and 50 pixels down. We can also use negative values if we want to. We can also combine multiple transform functions. First, let's rotate the box and then move it along the x-axis by 200 pixels. So we'll rotate it by 25 degrees and translate it 200 pixels. Now, when we save and hover over the box, this is what we get. Here, the order matters. If we change the order, the result looks different. Now, let's talk about CSS transitions. A transition lets an element change smoothly from one state to another. Here we have a box from the previous lesson. The only difference is it has a different background color. And when we hover over it, both the color and width change. Right now, that change happens instantly. To make it smooth, we use the transition property. The important thing is we apply transition property to box class, not to the hover state. So here, we're going to set the background color and width, because those are the properties that change when we hover over the box. Then we need to give a duration, let's say half a second. Then we add a comma and do the same for width. Here we can use the same duration for both, or give each one a different duration. For this example, I'm going to use the same duration for both. Now when we save the file, you can see the changes happen smoothly with a nice animation. We also have delay. This decides how long the browser waits before the transition starts. Let's add a 1 second delay to both properties. Now, when you hover over the box, nothing happens for 1 second. And then the animation starts smoothly. We also have the timing function. This controls how fast or slow the animation feels. The default value is linear, which means the animation moves at a constant speed. So, here I'm going to apply a timing function specifically for the width property. To make it easier to see, I'll remove delay value. For the timing function, I'll use ease in out. If we save this, you'll notice the animation starts slow, speeds up in the middle, and slows down at the end. So we have a few other timing functions. First, we have ease in. With this, the animation starts slowly and then speeds up. Next, we have ease out. Here, the animation starts fast and then slows down. Then we have ease in out, which we already saw. This one starts slow and ends slow. These are all pre-made timing functions. We also have a custom function called cubic Bezier. This lets us control exactly how fast or slow the animation moves at different points in time. Here's what these values mean. The first value controls when the animation starts changing speed. It's always between 0 and 1 and represents time on the horizontal axis. The second value controls how fast or slow the animation starts. A smaller value means a slower start, and a larger value means a faster start. The third value controls when the animation begins slowing down. The fourth value controls how fast the animation is near the end. A value of 1 means it reaches full speed before finishing. So this means the animation starts slowly, speeds up smoothly in the middle, and slows down nicely at the end. Now let's talk about animations. Animations let us move things in a smooth, controlled way. They're similar to transitions, but the big difference is we don't need an action to start them. In the previous lesson, when we hovered over the box, it changed because our mouse triggered it. But what if we want something to move on its own, without hovering or clicking? That's where animations come in. They can run automatically on the page. So as soon as the page loads, the animation begins automatically. To create an animation in CSS, we need two main parts. First, we define the animation using @keyframes. Keyframes tell the browser what should happen at different points in time. Second, we apply that animation to an element using the animation property. Let me explain this with a simple box example. Let's add some animation to this box using CSS. First, we position the box on the left side. Then, using keyframes, we define how it should move to the right over time. So let's say @keyframe. Here, we need to give a name to the animation we're creating. Let's call it MoveBox. This name is how we'll refer to the animation later when we apply it to an element. But remember, you can actually name it anything you like. Just make sure it's something meaningful so you know what the animation does. Inside the curly braces, we add from and to. From is where the animation starts, and to is where the animation ends. Here, let's set the initial position. So, let's say transform, translate, x, 0. So this means our box starts at its original position. Inside the to, let's set where the animation ends. So if we want the box to move 300 pixels to the right, we write transform, translate x to 300 pixels. Next, we need to tell the browser which animation to use. In the box class, let's add the animation-name property. We'll set it to MoveBox. Then we need to set the animation duration. Let's make this animation take 3 seconds. Remember, if you don't set the duration, the animation won't run at all. If we save this now, we can see the animation in action. We can also add an animation delay. Let's set it to 1 second. Now, the animation will wait 1 second before it starts. We can make this animation repeat as many times as we want. For that, we use the animation iteration count property. By default, it's set to 1. We can change it to 2, 3, or any number we want. If we want the animation to loop forever, we can set it to infinite. If we save this, you'll see the animation now runs forever. We also have the animation timing function, which works just like the timing functions we learned in the last lesson. Let's set it to ease out, so the animation starts fast and slows down at the end. There's also animation direction. The default is normal, which plays the animation from start to finish. We can change it to reverse, and it will start from the right side instead. There's another option called alternate. Now, as you can see, alternate makes the animation go forward, then backward, over and over smoothly. We also have a shorthand property called animation, which lets us combine all the animation properties into one line. In VS Code, if we start typing ANI, we can see the syntax pop up. Press Enter, and VS Code gives us all the placeholders. Now we can fill these placeholders with the same values we used before for the individual properties. Here, I'm going to remove the fill mode. Now, when we save this, it works exactly the same, but we're using just one property instead of many. We don't have to use just from and to. We can also use percentages to define keyframes. So, to represent the first frame, we can use the 0 present. Inside it, we define the styles for that frame. Let's say transform translate x 0. And let's also make the background color change while the animation is happening. So the box starts with a coral background color. Next, at 50%, let's change the background color to blue-violet. Then at 100%, we move the box to 400 pixels and change the color to green. You can add as many keyframes as you want, and the order doesn't matter. You can also space them however you like. Now, let's save and see how this looks. So this is how we add animations to HTML elements using CSS. Now let's talk about CSS Variables, also called custom properties. They let us store a value in one place and reuse it in many places. Think of them like little boxes that hold values. Here we have 4 elements. We have h1 header, a paragraph, a button, and div. If you look at the styles, you'll notice the same text colors, background colors, padding, and border radius are used again and again. Right now, that's not a big problem. But when a website gets big, these values might be used hundreds of times. Then, if you want to change one color, you'd have to search and update it everywhere, which is annoying and slow. That's where CSS variables help. To create them, we use the root selector at the top of our CSS. This is the global scope, so anything we define here can be used anywhere. CSS variables start with 2 dashes. Then we can type the variable name. For example, let's say primary color. Here, I'm going to set this color to the primary color. So, we've just created our first CSS variable. Now, let's create a second custom property and call it secondary color. And then I'll take the hex value from the text and paste it here. Next, I'm going to create 2 more custom properties, one for padding and one for border radius. Here, you can put anything you want into variables, but it really only makes sense when you plan to reuse them. Now that we've created our 4 CSS variables, we can use them by calling the var keyword. Inside the parentheses, we just put our primary color variable. Now I'm going to update the other properties using these CSS variables as well. Now, if we save this, you can see it looks exactly the same as before. So here's the cool part. If we want to change the primary color, we only need to update it in one place, and everything using it changes automatically. This keeps our CSS cleaner, easier to manage, and more flexible. It's also super useful when creating themes or keeping a consistent style across the whole website. In this lesson, let's talk about Flexbox. Flexbox is a CSS layout system that helps us arrange items easily. Instead of using float or complicated positioning, Flexbox lets us place items in a row or a column and control how they line up. Here we have a div with a class called container. Inside it, we have 4 divs, each with a class called box. These already have some basic styles applied. Now let's turn this into a Flexbox layout. First, on the container, we write display flex. As soon as we do that, the container becomes a flex container. And now you can see the boxes line up horizontally. That's because every direct child inside this container now follows Flexbox rules. Anything outside the container is not affected. To clearly see the Flexbox area, let's add a border to the container. Let's say border, 5 pixels, solid, light grey. So here's the Flexbox area. When we use Flexbox, the container creates 2 invisible axes, the main axis and the cross axis. By default, the main axis is horizontal. This depends on the flex direction property. The default value is row, which is why the boxes appear in a row. If we want the main axis to be vertical, we just set flex direction to column. Now the boxes stack vertically. We also have column reverse. Now the boxes appear in reverse order, from bottom to top. We also have another value called row reverse. Now item A moves to the right side, followed by B, C, and D. Next, let's talk about alignment. First, I'm going to remove the flex direction property. In Flexbox, there are 2 main alignment properties. We have the justify content and the align items. We use justify content to align items along the main axis and align items to align items along the cross axis. Right now, our flex direction is row, which is the default value. So the main axis is horizontal and the cross axis is vertical. First, let's see the justify content. The default value is flex start, so nothing changes. Items stay at the start. If we use flex end, the items move to the end of the main axis, in this case, the horizontal axis. And if we use center, the items move to the center of the container. We can also distribute items along the horizontal axis. First, let's look at space evenly. This gives equal space between every item, including the edges. Next, we have space between. Here, the first and last items are pushed to the edges, and the remaining space is placed evenly between the items. Next, we have space around. This adds space around each item, but the space at the edges is half the space between items. So justify content controls how items are spaced and aligned along the main axis. Now let's look at the Align Items property. This property aligns items along the cross-axis, which in this case is the vertical axis. The default value is Flex Start, so the items stay at the top, just like the Justify Content Flex Start on the main axis. If we use Flex End, the items move to the bottom, but only if there's enough space in the container. So let's increase the container height to 90 VH, which means 90% of the viewport height. Now if we save this, you can see the items move to the bottom. If we use Center, the items move to the middle of the vertical axis. Now let's talk about the Flex Wrap. This property only works when a Flex container has multiple rows or columns. So first, let's add more boxes to the container. If we save this, everything is still on one line. This is because the Flex Wrap property, its default value is no wrap. That means items try to fit into a single row. Now, let's change this to wrap. So now when there's not enough space, the items move to the next line. We also have wrap reverse, which wraps items in the opposite direction. Here, we can use Flex Wrap together with Align Content. First, let's set Flex Wrap back to wrap. Now, if we want to move all rows to the top of the container, we can set Align Content to Flex Start. Now all the rows move to the top and the space between them disappears. With Flex End, rows move to the bottom. With Center, rows move to the middle. With Space Evenly, rows are spaced evenly inside the container. And with space between, rows spread out with space between them. Now, what if we want to change the alignment of just one item? For that, we use the Align Self property. This property is applied to a Flex item, not the container. So let's change the alignment of the first box. First, I'm going to add an ID attribute and call it box-1. Here, if we want, we can also use a class selector or a pseudo class selector. Now, inside the styles, we target box1 and set the Align Self property to Flex Start. When we save, nothing changes because Flex Start already aligns items to the top. If we change it to Flex End, the box moves to the bottom of the container. We also have the Order property. Using this, we can change the order of Flex items without changing the HTML. Let's set the box1 order to 1. When we save, box1 moves to the end. If we change to order to -1, box1 moves to its normal position. So we can use this property on any Flex item to control its position. Now let's talk about sizing in Flexbox. The most important properties here are Flex Basis, Flex Grow, and Flex Shrink. These properties are applied to Flex items, not the Flex container. We use Flex Basis to set the initial size of a Flex item. The default value is Auto, which means the browser uses the width property. If we save this, you'll see there's no difference. If we set this to a different value, like 300 pixels, now the boxes become wider, even if a different width was set. Since our Flex Direction default value is row, Flex Basis controls the width. If it were column, it would control the height. We can also apply this to a single item. For example, if we set the Flex Basis of the first box to 100 pixels, that box becomes smaller than the others. So that's how we change the size of an individual item. Now, I'm going to remove this line because we don't need it anymore. Now, here, let's change this to 150 pixels. Now let's see the Flex Grow property. The Flex Grow property controls how much a Flex item grows compared to others when extra space is available. The default value is 0, so items don't grow. If we set Flex Grow to 1, now all boxes grow equally to fill the container. We can adjust the growth factor for individual elements. For example, if we set the first box's Flex Grow to 0, it won't grow at all. All the remaining space is distributed among the other boxes. If we change this to 2, the first box will grow twice as much as the others. Next, let's see the Flex Shrink property. The Flex Shrink property is the opposite of Flex Grow. It controls how a Flex item should shrink if there isn't enough space in the container. For example, let's set the initial box size back to 300 pixels. Now let's set the Flex Shrink to 1. This is actually the default. Now, when we resize the viewport, the boxes shrink at the same rate. If we set box 1 to Flex Shrink to 0, now the first box won't shrink, while the other boxes shrink to fit the container. This is very useful when you want certain items to maintain their size. We also have a shorthand property called Flex, which combines Flex Basis, Flex Grow, and Flex Shrink. If we set one value, it is treated as Flex Grow. If we set two values, the first is Flex Grow and the second is Flex Shrink. If we set three values, the first is Flex Grow, the second is Flex Shrink, and the third is Flex Basis. Both Flex Grow and Flex Shrink are unitless and work as proportions. This shorthand makes Flexbox sizing much easier and cleaner. In this lesson, let's learn about the grid system. Grid is built for two-dimensional layouts. It helps us place elements into rows and columns, which makes page layouts cleaner, more flexible, and easier to manage. The big difference between Flexbox and Grid is how they work. Flexbox works in only one direction at a time, either a row or a column. It's mainly used to line things up in a straight line. Grid is different. Grid works in both directions at the same time, rows and columns. That's why Grid is perfect for two-dimensional layouts. We can place elements anywhere we want, even stack them if needed. In Grid, everything is based on lines. Each number represents a line. Some lines go across for rows, and some go down for columns. The space between these lines creates cells. Each square you see in a grid is called a cell. To create a grid, we need a container and some elements inside it. Here we have a parent element with 4 child elements, just like we did with Flexbox example. We usually call the parent the grid container, and the children are called grid items. These are the basic styles for the container and the items. First, in the container class, we set the display property to grid. When we save this, nothing seems to change. That's because a grid needs rows and columns. We have to tell the grid how many rows and columns we want and how big they should be. If we don't define them, the browser will decide automatically. In this case, the browser creates 1 column and 4 rows by default, but we can control this ourselves. To define columns and rows, we use the grid template columns and the grid template rows. Let's say we want a 4x2 grid. First, we define the columns. If we want 2 columns, each 100 pixels wide, we write 100 pixels and 100 pixels. Here, each value represents a column that is 100 pixels wide. Next, we define the rows using the grid template rows. Since we want 4 rows, we write 100 pixels 4 times. Now we have 4 rows, each 100 pixels tall. To understand the grid better, let's open the browser's developer tools. If we look at the container in the DOM, we'll see a small grid icon. When we click it, the grid layout appears on the page. Now we can clearly see a grid with 4 rows and 2 columns. There's also a Layout tab in the Dev Tools. From there, we can turn grid options on and off, like showing line numbers. We can also see track sizes. Tracks simply mean rows or columns in the grid. Right now, all the cells are the same size. We can easily change the size of just 1 column or 1 row by changing its value. For example, if we set the first column to 300 pixels, you'll see that the first column becomes much wider than the others. When we set up rows and columns, we don't have to use fixed pixel values. We can also use units like EM, REM, and percentages. Grid also gives us a special unit called FR, which stands for fraction. And FR is just a part of the available space. For example, if we set the columns to 1FR, 1FR, we get 2 columns that share the space equally. Each column takes up 1 fraction of the available width. You can see the grid stretches across the full screen. And if we resize the browser window, the grid adjusts automatically. Now, if we change the second column to 2FR, you'll notice the second column takes up more space. That means the second column is twice as wide as the first one. We can also mix FR units with other units. For example, if we set the first column to 100 pixels, the first column stays at a fixed width. The second column then takes up all the remaining space. When we resize the window, the first column stays the same size, but the second column grows or shrinks based on the screen size. We can do the same thing with rows using FR units too. Right now, we have a grid with 2 columns that fill the full width of the container. If we add another column, you'll see it gets added to the end of the first row, and it still stays inside the container. But this doesn't always work the same way when we use percentages. Percentages can be a bit tricky in grids, so as a best practice, it's usually better to use fractions instead of percentages when defining grid rows and columns. Here, if I resize the window, you can see that the second box becomes much too thin. To stop that, we can set a minimum width using the min-max function. Let's apply this to the second column. We just use min-max with parentheses and define the minimum and maximum values inside it. Inside the parentheses, we give two values. The first one is the minimum size, and the second one is the maximum size. I'll set the minimum to 300 pixels and the maximum to 3FR. Now when we resize the window, the second column will stop shrinking once it reaches 300 pixels. So this is how we can define a minimum and maximum size for grid columns and rows. Now let's talk about the repeat function. When we create rows and columns in a grid, we often end up typing the same value multiple times. Later, if we want to change the size, we have to change it everywhere, which is a hassle. The repeat function helps with this. We use repeat and pass two values. The first value is how many rows or columns we want. The second value is the size for each row or column. First, let's rewrite the grid template columns property using the repeat function. Inside the parentheses, the first value is how many columns we want, in this case, 2. The second value is the size of each column, let's say 100 pixels. We can do the same for rows. We want 4 rows, so the first value is 4. And the size of each row is 100 pixels. Now, if we want to change the size or number of rows or columns later, we can do it easily in one place. We can also combine the min-max function with repeat. For example, let's say we want all columns and rows to have a minimum size of 100 pixels and a maximum size of 300 pixels. Inside the repeat function, for the second argument, we can use min-max. So we write it like this. So this is how we use the min-max function together with the repeat function. We use repeat to tell how many columns or rows we want. And inside that, we can use min-max to set the minimum and maximum size for each one. We also have grid template, which is a shorthand for grid template rows and columns. First, we write the template for the rows. Let's say repeat 4 100 pixels. Then we add a / and write the template for the columns. Let's say repeat 2 100 pixels. After this, we can remove the separate grid template rows and grid template columns lines. Right now, our grid items are all right next to each other. We can add space between rows and columns using the row gap and column gap properties. Here, let's set row gap to 10 pixels. Now there's a 10 pixel space between each row. We can also set column gap to 10 pixels to add space between columns. We also have the shorthand property called gap. If we want different values for rows and columns, we can write it like this. If we want the same value for both, we just write one value like this. Now all the grid items have a 10 pixel gap between them. Now let's look at aligning items in a grid. We have two main properties for this: justify items and align items. Justify items aligns items along the horizontal axis, and align items aligns items along the vertical axis. By default, both are set to stretch, which is why our boxes fill the entire grid cell. First, let's look at justify items. To make this easier to see, let's give the boxes a fixed width and height of 50 pixels. Now, the boxes are smaller than their grid cells, so we can see the alignment more clearly. With justify items, we can change the default value to start, end, center, and more. This property controls the horizontal alignment. If we set it to center, each box will be centered along the horizontal axis of its grid cell. Now we can use align items to control the vertical alignment of the boxes. Just like justify items, it can be set to start, end, center, and so on. If we set both justify items and align items to center, the boxes will be perfectly centered inside their grid cells. Now let's see how to align items individually. For that, we can use justify self and align self on the grid items themselves. For example, let's change the alignment of box 1 only. We can set justify self to end to move it on the horizontal axis. Then we can use align self and set it to self end for the vertical axis. So with these two properties, we can control the alignment of individual grid items without affecting the others. Now let's take a look at how to align the grid. To keep things simple, I'm going to remove these lines for now. If you look at the grid right now, you'll notice it's aligned to the left side of its container. We can change this using the justify content and align content properties. Justify content controls the alignment of the columns. We can set it to values like start, end, or center. If we set it to center, the grid will be centered horizontally inside the grid container. Align content controls the alignment of the rows. If we set this to center, the grid will be centered vertically. But if we save this, you won't see any change because the container automatically grows to fit the grid. To fix that, we need to set a height on the container. Let's set the height to 100 viewport height, which means 100% of the viewport height. Now you can see space at the top and bottom, and the grid is perfectly centered inside the container. Remember, the grid is centered within the grid container, not across the entire web page. Here's an important distinction. Content refers to the entire grid as a whole. Items refer to the individual elements inside the grid. Now, let's talk about placing items in a grid. By default, each grid item takes up one cell. But if you want an item to span across multiple cells, we can control that using specific grid properties. For this, we have three properties, which are grid row, grid column, and grid area, which is the shorthand for grid row and grid column. By setting these properties on an item, we can control where exactly that item should be placed. For example, let's say we want the first box to take up the entire first and second rows. So for box 1, we'll start by setting the column position. Here, we need to provide two values. The first value is the starting line number, and the second value is the ending line number. In this case, the starting line number is 1. Then we add a / followed by the ending line number, which is 3. Now, if we save this, you can see the box 1 takes the entire first row and other boxes pushed because we aren't explicitly defining their position. Here, we can also count backwards, so -1 represents the last column. Here you can see we get the same result. So 3 or -1 are the same thing. But for now, I'm going to change this to number 3 again. I want to show you we can also use the negative numbers. But here we need this box also take up the second row also. So for that, let's set the grid row property. So start line number is 1, and then after the / we need to add the end row number, which is 3. Now you can see the first box stretches the 2 columns and 2 rows, and other boxes pushed. Here we can also use the span keyword to specify how many cells this item is going to take. We can say it's going to span 2 cells. And here we can also change to span 2, because the box 1 spans the first 2 rows also. Basically, the span keyword is saying from wherever you currently are, span yourself this number of times. We also have the grid area property. First, we need to pass the start values, which are start row number and the column number. Here it's 1 and 1, and we need to separate them using a /. Then we need to add the end values. Let's add a / and then add the end row and the column. Here it's 3 and 3. So we get the same result. The first 2 numbers represent the start, and the second 2 numbers represent the end. Now let's look at another way to position items in the grid that doesn't require us to count line numbers. We can do this using grid template areas and grid area. On the container, we use grid template areas to define the layout areas. Then, on each grid item, we use grid area to place it in a specific area. Now let's set up grid template areas. Here you can see that our grid is made up of 4 rows and 2 columns. We start by adding a pair of double quotes, which represents the first row of the grid. For the first row, if we want 2 cells, we can give each cell a name. For example, header header. This means the 2 cells in the first row are both called header. Next, we add another pair of double quotes for the second row. In this row, we want a navbar and a content area, so we write nav content. The names are totally up to you. You can call them anything you like. For the third row, we also use the same values as before. For the last row, we want 2 cells for the footer, so we add another pair of double quotes and write footer and footer. I used 4 lines of quotes because my grid has 4 rows. Inside each line, I wrote 2 names because the grid has 2 columns. Think of it this way. 1 line of quotes equals 1 row, and each word inside that line stands for a column. Now we have defined different areas: header, nav, content, and footer. If we open the Developer Tools and go to the Layout tab, we can turn on Show Area Names. Once we do that, you'll see the area names we set appear on the grid in the correct places. Next, we assign these areas to our grid items. For example, we can make Box 1 the header, Box 2 the navigation, Box 3 the content, and Box 4 the footer. Using the grid area property, we can easily assign each box to the area we want. For the first box, we set grid area to header. Notice that we just type the area name without quotes. Using quotes here won't work. This way, instead of giving exact line numbers, we can place items by name. We can do the same for the other boxes, assigning each one to its corresponding area. Now you can see that each box is sitting in the section we assigned to it. Using this method, we can easily create any website layout without worrying about the grid line numbers.